But before we can do that, we need to do some more double and compound angles. So we've got a question up. Just in terms of running back what we did before. So this was on Tuesday, and I think we must definitely just practice a bit more, because there's still, I think some of you still need a bit of practice with this. So that's what we did on Tuesday. We started off just doing reductions, and then we started doing numerical reductions. So reductions where they are numbers. So let's have a look at this first one. And I did ask everyone who came into the lesson to start working on it. But basically, we're going to I'm going to do this first one, and then you can give the second one a go on your own. Okay, and remember, you are welcome to take screenshots. If you're on your phone, you're welcome to take screenshots of everything that we do, the questions that are up, the questions we don't necessarily always get to. You're welcome to take screenshots so that you have those. In any case, let's go. Let's see. Sine of 134. Now, 134 is in the second quadrant. So that's always our thought process. We identify, first of all, what quadrant the angle is in. So 134, and I'm going to draw the Cartesian plane very wobbly over here. Imagine that is straight, but this is my first quadrant, my second quadrant. So 134 is in the second quadrant. The second quadrant is the 180 minus x quadrant. In other words, what must I subtract from 180 to get 134? So that you can just quickly do on your calculator, and that gives you 46. Okay, so that's what we mean with reductions. We reduce all angles that are non-acute to acute angles, and this is the process by which we do it. Quadrant, then we say, okay, what must I subtract from 180 to get 134? That is 46. So that's going to be sine of 46, and sine in the second quadrant is positive, so we're just going to leave it like that. Now, if you are still confused about reductions, I want you to go on your calculator and say, what is sine of 134? I get 0.7193, and then also do sine of 46, and you'll see you get the same, 0.7193. Okay, so sine of 46 and sine of 134 is exactly the same number. Okay, so those numbers are equal, but we always reduce to an acute angle. That's what reduction is all about. Right, let's do the next one. Sine 337. 337 will definitely be in the fourth quadrant. So the fourth quadrant is 360 minus x. What must I subtract from 360 to get 337? 360, that gives me 24. So sine, sorry, 23, sine of 23. But sine in the fourth quadrant is negative. So we need to make that negative. Okay, now cos of 157. And I'm going to do cos of 157 just over here as a little bit of an aside note, negative 157. Okay, so the best thing to do with these negative angles is to add 360 degrees to it. The reason we do that is because it is going to make that angle positive, and you're not doing anything wrong because you are just basically adding a revolution by adding 360. So you get cos 203. Okay, now that is easier to reduce than the negative 157 because it's a positive angle. So 203 is going to be in the third quadrant. The third quadrant is 180 plus x. So what must I add to 180 to get 203? And that is 23. So cos, that'll be cos of 23. And we also need to make it negative because 203 is in the third quadrant and cos in the third quadrant is negative. Okay, so I hope everyone has managed to, has understood what we just did. I see some people are putting answers, which is absolutely excellent. I am really pleased to see some answers already. Well done. Okay. I just want a check in the chat. Put a thumbs up, thumbs down if you are happy with what we just did and how we got to this point with the sine 46, the negative sine 23, and the negative cos 23. Because there's a lot. Trig is very detailed. There's quite a few steps in everything that we do. And I think that's why people find trigonometry sometimes a bit challenging, because there are so many things that you need to remember and do. But the more you practice, the better you will become. I promise you that. Okay. Ms. Coco and I only know trigonometry as well as we do because we've practiced it so much. Hey, Ms. Coco, how much have you practiced trigonometry?
I used to go to school Mondays to Sundays, so I was that kind of maths nerd. So yeah, I used to practice quite a lot.
Hours and hours. But don't let that put you off. I mean, it just means it's completely doable. And it doesn't take some magical power to do trigonometry. It's just practice. Okay, Oko, you have your hand up. Go ahead, ask your question.
Yes, ma'am. On that minus cos 23, I didn't get it because the network is giving me trouble. Network is giving me trouble.
Okay, so we look at sine 337. 337 is in the fourth quadrant. Yes, that is the 360 minus quadrant. So we have to subtract 23 from 360 to get 337. So that's why we change it to sine 23. And then because sine is negative in the fourth quadrant, we make it negative sine 23. Okay. Okay, ma'am. Thank you. Sure, no problem. Okay, so sine 46 at the top, a negative and a negative makes a positive. So that gives me sine 23 and cos 23. So what you need to start noticing here is that the 23 and the 23 make a 46. So there's a double angle here. So sine 46 is, and I'm just going to also do it here, sort of like my working out thinking. 46 is 2 times 23. Okay, so that's where the double angle comes from. So we can expand that using the double angle identity for sine. And again, you don't have to memorize it. It's all on your formula sheet. And I'm actually going to go get the double angle identities from this lesson we had here. And just paste them here so that we have them at hand. So sine of 46 is sine of 2 times 23. So we can change that to 2 sine 23 cos 23 over sine 23 cos 23. Okay, and obviously these divide evenly, cos 23 and cos 23, sine 23 and sine 23, and we have 2. Our answer is 2. Awesome. I see a few of you got that answer. If you got the -2, just check. Probably something went wrong somewhere with the negative sine 23 and the negative cos 23. So just double check your answer. Okay, right. Let's go on to question 2. And I'm going to give you a chance to do that one on your own. I'm going to give you about 4 minutes. We've done question 1. We are now on question 2. 4 minutes, and we'll check back in here at about 17:21. Right, let's have a look. So we've got cos squared 148. 148. Let's draw our quadrants. See, some of you got answers. Wonderful. Let's see. So cos of 148. So 148 is in the second quadrant. So we reduce it. What must I subtract from 180? So it's 180 minus x. What must I subtract from 180 to get 148? And that is 32. Now, cos is negative in the second quadrant, but because we are squaring it, it just stays positive. So you can leave it as cos squared 32. Then sine of negative 32, you can add 360. Let's do a bit of thinking over here. Negative 32 plus 360. That gives me negative 32 plus 360 gives me 328. So what must I subtract from 360 to get 328? And that is 32. So it actually reduces to sine 32. And because it is in the fourth quadrant, it is negative. So that's where my negative sine 32 comes from. Then sine of 392, that is actually greater than 360. So we go past 360 and that's another, so we go 392 minus 360, that gives me 32. And that is in the first quadrant. If you are doing an angle that's bigger than 360, then you can just subtract 360 from it, and then you get what the actual angle is. In this case, it's just 32, and that's in the first quadrant. So we leave it as sine 32. Now, sine 206. 206 is in the third quadrant, so that's 180 plus x. So the 180 plus x, what must I add to 180 to get 206? And that gives me 26. Okay. So we've got now cos squared 32 minus sine squared 32 over negative sine 26. Now, at the top, we should recognize the double angle for cos. And remember, you take the angle, the 32, so the double angle is 64. So this is, in fact, cos of 64 over negative sine of 26. And we had this on Tuesday as well, where the angles, if they add up to 90 degrees, cos and sine, they actually cancel out. So our final answer is -1. I see ones and negative ones. So if you are doing a -1, that is correct because it's negative sine 26 at the bottom and cos of 64. So well done if you got -1. If you got 1, just double check your answer. Okay, well done, Susisa. Looks like you got that one right. That's excellent. Okay, I think let's do question 3 as well. And yeah, let's do question 3. And we'll check back at 5:30. Mohammed, take some time to check your work. If you're not sure something's right, then just check. Always just double check. Miss Coco, I think our work here is done.
I mean, we can just give the reins to Mohammed and he'll take it away. I believe you could. Yes, sir. Well done.
Yeah, it's good to know that, yeah, people can. Okay, so let's have a look, everybody. So 2 cos squared 204. That is in the third quadrant. Again, we are squaring cos. Even though cos is negative in the third quadrant, we square it so it stays positive. So we just make it cos squared 24. Then sine of 150 is in the second quadrant. That's 180 minus 30 will give you 150, and sine is positive in that quadrant, so we just leave it as sine of 30. Then cos of 320 is cos of 40, because that's in the fourth quadrant, and cos is positive in the fourth quadrant. Cos of minus 8 degrees is also positive, it's cos of 8 degrees. And then sine of 220, 220 is in the third quadrant, so it's negative sine of 40. And then cos of 82, we start to notice that we've got cos 40, cos 8, sine 40, sine 8, sine cos 82, and it's starting to look like a compound angle expansion. So that's why we then use the 90-degree rule to change cos 82 to sine of 8. So we've just applied our 90-degree rule there. Okay, so in the next step, all we do is we change the sine 30 to a half. And now you'll see that the magic happens, because we can go 2 cos squared 24 minus 1, which is double angle. And then cos 40 cos 8 minus sine 40 sine 8 is cos of 40 plus 8. That is a compound angle. So at the top, we have double angle for cos, and at the bottom, we have compound angle. The compound angle identity of cos A plus B. Okay, so at the top now, we can simplify that. That's double angle, so that is cos of 2 times 24, so that's 48, cos of 48. And at the bottom, we have cos of 48, and it all boils down to 1. Okay, so 1 is the right answer. If you've got -1, you probably went wrong. I'm not sure where, because in your previous steps, for everything to have worked out, yeah, just double check where it went wrong with the cos of 48. Yeah, which maybe somewhere there was a sign that wasn't correct. Okay, so what we're going to do next is, I think just a quick, I think we've got 10 minutes left, and I think that's enough time for one equation. Solving trig equations with compound and double angles. So there is a little bit of a refresher here of stuff we've done before, doing maybe 2. I think we can do it. We still have a lot to get through, Ms. Coco, but thanks for the vote of confidence. Okay, so maybe we should just jump right down to the equations with the compound and double angles. So yeah, let's do it. Let's go right down here and do those ones. Let me just make space here. Look how much I planned for us to do. I think I was even more hopeful than you. Okay, so we've got 2 sine 2 theta is equal to 3 cos theta. So have a look so long. We're solving for x, and I'm going to give you a minute to think about it. Okay, so we should all have seen, hopefully, that the sine 2 theta, we can expand that using our double angles for sine. So the sine 2 theta, we can replace with 2 sine theta cos theta, and put what you change, always put it in a bracket so that you know that you have to multiply it and do everything you need to do. Because then the 2 times 2 sine theta cos theta will be 4 sine theta cos theta equals to 3 cos theta. Okay. We're going to bring the 3 cos theta over to this side, and that's going to be 4 sine theta cos theta minus 3 cos theta equal to 0. Now we can take out a cos as a common factor. Cos theta leaves me with 4 sine theta minus 3 is equal to 0. Belinda's quick. She's got an answer already. Linda, make sure that that is correct. Okay, that means that cos theta is equal to 0, and then 4 sine theta minus 3 is equal to 0. Now if you remember from what we did before in our previous course on trigonometry, now is the time to find your reference angle. When you have your trig ratio equal to a number, so when the trig ratio is by itself equal to a number, then you can find reference angle. So cos theta equal to 0, we just go shift cos 0, that gives me 90 degrees. So theta is 90. And here we need to still do a bit more work. Take the 3 over, negative 3 over, and then divide by 4. And then we get our reference angle over here by going shift sign 3/4. And that is 48,59. So Belinda, you've got one of the reference angles, but I think there might be a solution missing with the cos theta equal to 0. Okay, so we are going to do the general solution here, just to revise that as well. So general solution means you have to look at your quadrants and you have to solve for both quadrants. So, but for cos of 90 degrees, so that is where cos is positive. So that is in the first and the fourth quadrant. So our first quadrant solution is 90 plus k times 360, where k is an integer. And the reason we do positive is because we always take 0 as positive, okay? And cos is positive in the first and the fourth. So our fourth quadrant solution will be 360 minus 90, because that's our reference angle, plus k times 360. And that gives us 270 degrees plus k times 360. Okay, that's for cos theta equal to 0. Now we do sine theta equals to 3/4. General solution is always in your paper, and it's normally with graphs, and it can count up to 7 marks. So if you practice these lots, then you can score quite a few marks. So sine we are doing also where it's positive. Sine's positive in the first and the second quadrant. So we do our first quadrant solution, and that is theta is 48,59 plus k times 360, where k is an integer. And then our second quadrant solution is 180 minus 48,59 plus k times 360. And that gives us 180 minus 48,59 is 131,41 plus k times 360. Okay, so that is just one sort of example of where we are using double angles to do general solutions. And it's normally just at the start of the general solution where you have to either change sine to theta or cos to theta, and then get your trig ratio by itself, and then from there on. So the work is really at the start. As soon as you get your trig ratio by itself with your reference angles, then it's pretty standard from there. Then it's just normal general solution like you always do, and which we revised. If you've already forgotten your general solution, go watch the lessons again that we did earlier in this term on general solution. We did quite a lot of them. And we went through all the different types of questions that you can have, etc. I see there was a question, but Ms. Coco answered it. Okay, cool. Right. Ms. Coco, you were hopeful that we were going to do 2, but I doubt that we are going to. We have run out of time. You forgot that it's general solution and that it takes a lot of time to do general solution.
And it's quiz night, so.
Yeah, but you guys are welcome to take a screenshot of these 3 questions and go practice them. You just literally have to use your compound, and well, these are all double angle ID.